Welcome to clickmeproject.com. Let me discuss about the process shape similarity analysis by self-tuning locally constrained mixed-diffusion. Let me see about the process shape similarity analysis by self-tuning locally constrained mixed-diffusion. In this process, initially the similarity between the shapes were analyzed and the similar shapes were retrieved. Here, for analyzing the similarity shapes, we employ the feature extraction algorithms such as shift and the GLCM algorithms. The shift algorithm extracts the edge-based information from the image, and the GLCM algorithm extract the gray level based values from the images. So these values were saved as features and they are passed into the support vector machine classifier. The support vector machine classifier classifies the images based on the features extracted and the two labels setup. So the trained images will give the exact correct answers, and after that the equivalent distance is measured between the test image and the trained features, and the images that are having the low gradient distances were taken and they were retrieved from the database. So these contain mostly similar images which represents the input image. So thus we are producing a retrieval system that retrieves mostly correct or most correctly the similar shapes from the database. There may be also some misclassifications and misretrieval of the images. If we see the flow of the process, shape similarity analysis by self-tuning locally constrained mixed-diffusion. Initially, the test image is taken and it is pre-processed. In pre-processing, we apply median filter. Median filter is used to remove the noises from the input images. It is often desirable to perform some kind of noise reduction on an input image. Median filter is a non-linear digital filtering technique often used to remove noise. Such noise reduction technique is a typical pre-processing step used to improve the results in the later processing. Median filtering is very widely used in digital image processing. After pre-processing, we are extracting the features from the input images. In order to extract features from the images, we use shift and the GLCM algorithms. Shift features were extracted from the input images. These shift features shows us the shift features gives us the edge information of the input image. The input image may contain some the needed in the clearly visible edges were extracted from the shift features, and then the GLCM features gives the texture based information related to the image. So the GLCM features shows us the grayscale changes in the input images, and which describes the in processing which describes the grayscale values within the image. These features were extracted and then they are saved. The same procedure is used in the training images. So for all the training images, features were extracted and then they are passed into the classifier. So for classification, we are using a support vector machine. So the support vector machine classifies the input shape into the corresponding shape depending on the trained images, and then using the equivalent distance, the features extracted. The objects having the minimum distance were extracted from the dataset, and the value and the similar images were retrieved. We discuss the execution of the process shape similarity analysis by self-tuning locally constrained mixed-diffusion. If you want to run the code, select the file m.main.m, which is located in the source code folder. Right click it and click on run file. You will get the guide window. This guide window contains all the user interfaces needed in order to run the code. First select the training data, browse your system and select the folder training set which is presented in the source code folder and click OK. Now all the images in the training set folder were feature extracted and the results were displayed here. Now the features are extracted for all the images, and then select a query image which is presented in the test set. So we apply pre-processing, then features were extracted for the image. Then after feature extraction, we apply the classification. So this image is classified as apple, and then similar shapes were retrieved from the dataset. Here some of the images were wrongly retrieved, and also there will be some misclassifications for classification also. So finally we are identifying the input shape and classify it, and we are retrieving the similar shapes from the dataset. For that we are using real time and shift feature completely, uh, they are passed into the classifier and the shape table. For classification we are using clean and classifier, and for classification we are using SVM classifier, and finally we are retrieving similar images. Thank you.